morning, introduced Bosch.
Dr. Michael, 1 minute.
Okay.
The microphone's not working. We'll try this one.
Oh.
It's on now. Just speak.
Hello? Good. Okay, again, good afternoon. This morning, Rainer Kallenbach introduced Bosch, and later on, John Cohn give an explanation about blockchain, very clear and comprehensive, so I can skip these both topics. I would like to talk about use of blockchain within Bosch and present a proof of concept which we have done for fake recognition, the fake detection in the automotive aftermarket. This proof of concept we have developed together with IBM. The blockchain is well known in the financial sector. I think you all know Bitcoins. Some of you owns Bitcoins. But the technology is applicable universally. The strength of the blockchain is in intercompany business, and we see a lot of processes supported by the blockchain, like in the manufacturing chain, supply chain, logistic, also in the warranty handling. It's about the proof of concept, and also in software integration and software handling. A wide area is commercial transactions in the share economy, car sharing, for example, rental services, also later on also in the autonomous machine economy. In the IoT area, we see blockchain support safeguarding, for example, software over the air, or in the connected cars area and interconnecting devices. An advantage of the blockchain is that we have no need for proprietary platforms, and we are not bounded to providers. Now I explain our proof of concept. It's about fake detection in the automotive aftermarket. And here we have the problem that a certain percentage of warranty cases, there are fake products behind. For us, it's very expensive to prove that a certain warranty case says no Bosch product behind, no gene in Bosch, it's a fake. And this is very expensive. And so, with this proof of concept, we tried to improve this process. Let's assume a product is produced in one of our plants in China. Before leaving the plant, the product is registered in the blockchain with a number of information. In the following, all transactions related to this product will be recorded in the blockchain. So we have the whole history of the product then in the blockchain. That means it's unchangeable, secure, and all participants have access to the data. The product then is shipped, let's say, to the warehouse in Germany, and then via distributors to the target destination. In a garage, finally, the product will be installed in a car. So when the product fails, then it will be sent back to the warranty handling unit. And now we are able to check very fast that whether the product is a genuine Bosch product or it's a fake product. The proof of concept we realized on Hyperledger based on open source and open standards. We have a modular and scalable architecture behind. It's a permissioned blockchain, so we have pretty good performance. And data privacy and confidentiality is assured by design. Advantages we have a transparency on the whole product logistics. We can very fast check whether there's a fake product, and also we are able to identify gray market imports. We see big potential for cost savings in the warranty handling process, and also with this proof of concept, with a use case, we see other business cases which we can handle also. Here is the architecture of the proof of concept. We implemented the software in Docker containers, and the Docker containers are distributed in this case, 4 data centers. You see the locations: Frankfurt, Sydney, Chicago, and Houston. This is clear, our IBM data center. We are open. The Docker containers could also be copied to other data centers. Actually, we have now a 5th data center, which is in the Azure cloud. And in the next time, we will also copy one of the Docker containers into our Bosch IoT cloud. On the right top, you can see a dashboard we implemented. So you can see the nodes of the blockchain with the status behind, and also all transactions running on the blockchain. We see for each product the product ID, a description of the product, and also the status of the product. Whether it's a genuine Bosch product, a fake product, or a suspicious product. We also record the scanning device and the geolocation so that we have a number of plausibility checks implemented. On the left top, you can see our user interface. It's based on a smartphone app, which can be used by our employees, but also by the end customer. The end customer can also scan a Bosch product and check whether it's a genuine product. 2 points I would like to emphasize. 1, we are very open with the Docker container principle. We are not dependent on any provider. We can copy the Docker container into every data center and every cloud. And second, we have an open interface and standard protocols to the blockchain. So every partner can implement its own user interface with its own branding and also work with this blockchain. Summarized, we had a very good cooperation between IBM and Bosch. The implementation has been done within 3 months with a very small team from both sides in the joint client lab of IBM. We have a high probability that we will extend the proof of concept now and migrate into the productive use. And for the use cases, we are just in evaluation. For example, in the logistic chain, in the sharing economy, supply chain, and also a very interesting project which is just running within Bosch is community-based parking. And for the future, we think about very complex use cases involving IoT devices from the medical area using blockchain and Watson IoT in combination. Thank you very much.